So before we start defining domain and range, I want to be sure we go over interval and set notation, because having these ideas down can really be beneficial in our course. So what this is going to start with is we're going to start with an inequality. So we have these different forms on the left-hand side. And what we're going to do is translate it into a graph and then translate to interval notation and translate that into set notation. Now, sometimes questions will specify like use interval notation or use set notation. So you don't need all 4 of these forms every single time. I will say the graph is usually very helpful, especially when you have the idea of infinity in there. But we should be able to kind of jump between these different forms here. So the first case, x is greater than 2. That's what this is defining here. Let me even write that out in words. X is greater than 2. Now, if you're having trouble with the direction of which way the inequality is going and you're not sure which is bigger, which is smaller, I always go back to the old trick of the alligator mouth of an inequality symbol looks like a mouth being open, and the mouth is going to open towards the bigger thing. So with this one, x is the bigger thing because that alligator mouth, if you imagine like little teeth in there, is going towards x, and then the 2 is on the smaller side, so it's like the alligator's facing away from it. So 2 is smaller than x, or x is greater than 2. Those are both definitions here. So if we draw a graph, I'm going to draw just a really simple graph here in terms of a number line. That's what this means when you're graphing inequalities like this. You're just graphing a number line. So I'm just going to put the number 2. I'll go 1 above, so 3, and 1 below to positive 1. Now, this symbol here is strictly more than. This doesn't have the equal part to it. If there was a line underneath, then it would be greater than or equal to, but this is strictly greater than. So what that means is that if I'm graphing this inequality on a number line, at 2, we're going to have an open circle. So we're going to get infinitely close to positive 2, but we're not including 2 itself. And if we're greater than, then we want to go to the right-hand side. So like where 3 is, we want to grab these larger numbers. So I'm going to shade into the right-hand side, going off to bigger and bigger values as we go off to positive infinity there. So my graph starts at 2 with an open circle and goes off to infinity. Interval notation. So interval notation is going to use parentheses, and they might be the curved parentheses, or we might use the square brackets, or some form of combination of the two. The square brackets will be used when we have that equal sign in there. So if this was greater than or equal to, then we would want to use that square bracket by the 2 to show that we're including it. But we don't have that here, so we want to stick with the curved parentheses. So in terms of interval notation, our 2 values, so reading left to right, we're starting at 2, and then we'll go comma, and then off to positive infinity. And next to the 2, I'm going to use the left-hand parentheses to show we'll be at 2, but not including. And then with infinity, you always use those curved parentheses because we're not including infinity. So 2 comma infinity stuck between 2 curved parentheses. Set notation is really just going to use that inequality form that we started with, just with a little bit of special extra notation in there. So what we're going to do is we're going to have these curvy brackets. So curved brackets, and then I'm going to have x and then a tall vertical line. What this says is x is defined by ... and then we're going to define x. So this is describing a set of values that works for x, and then I'm just going to use that inequality notation, which is that x is defined by x is greater than 2, and then close those curvy brackets, and we're done. All right, so that was all for x is greater than 2. This next one, we see x, and then we have the less than symbol, so the alligator mouth is pointing towards the 8, so 8 is the bigger thing here. But then we also have that line underneath, which says that we can also equal 8. So what this is x is less than or equal to 8. So, drawing a graph, I'm going to graph a number line. I'm going to just put 8 in the middle, but then I'll go 1 above to 9, 1 below to 7. At 8, since we have that equal to, I'm going to have a solid circle at 8 to show we're including 8 itself. And then because we want the smaller values, we want to shade off to the left-hand side. So I'm going to make it colored into the left-hand side, so towards 7, going smaller and smaller, and out to negative infinity. All right, so our set notation. So reading left to right, we're starting at negative infinity, and I'm going to have comma, and then our largest value is 8. Again, with infinity, you'll always use those curved parentheses, so I'm going to have that left-hand parenthesis, and then with 8, because we're including 8, I want to use that square bracket. So I'm going to use that square bracket with 8. Then for set builder notation, I'm going to use the curvy bracket, x, tall vertical line, so x is defined by, and then we'll have x less than or equal to 8, just using that notation from that first column. All right. Let's see, here we have 2 is less than or equal to x is less than or equal to 5. So 2 is less than or equal to x, and x is less than or equal to 5. So really x is stuck between two values, 2 and 5. So let's draw a graph. I want to see that lower value of 2 and that upper value of 5. So I'll go 2, 3, 4, 5. So we have the equals with both of these values. So at 2, I'm going to have a solid circle to show we're including 2. At 5, we'll also have a solid circle to show we're including 5. And then x is between those two values. So I'm just going to shade in between so that we can see we have 3, we have 4, and any decimal between 2 and 5 is included. All right, so for our set notation, our lower value is 2, and then comma, upper value of 5. We're including both of those endpoints, so I want to use square brackets for both. And then for set builder notation, I would use curvy bracket, x is defined by, and then 2 less than or equal to x less than or equal to 5. Okay, let's see, 2, 3 more. All right, 4 is less than x is less than or equal to 6. So this is similar to up above, but I just took out the equal sign on one of them. So I'm just going to write this out in words. So 4 is less than x. So notice there we don't have the equals. And x is less than or equal to 6. So for a graph, I'm going to have my number line. Let's see, I want to go from 4, 5, 6. At 4, we're going to have an open circle because we don't have the equals there, but 6 will have a solid circle since we do have equals there. Then I just want to shade in between those two circles there. So the lower bound value is 4, upper bound value is 6, so 4 comma 6. At 4, I want to use the curved parentheses because we're not including the 4, and at 6, I want to use the square bracket to show that we're including that endpoint of 6. And then for set builder notation, curvy bracket, x is defined by 4 is less than, is less than x is less than or equal to 6. All right. Well, this doesn't make any sense here. I think I left out x. Negative infinity is less than 4, or 6 is less than or equal to infinity. That doesn't make any sense. So let's say, oh, this might not work either. Let's go ahead and skip that one. Sorry, I just messed up the notation and x is missing. So we're going to skip that one and jump down to the end here. And let's make sure this makes sense. So negative infinity is less than x is less than 4, or 4 is less than x is less than infinity. So let's go ahead and just start graphing this one instead of writing that out in words, because maybe shading in on the graph will just help it make a little bit more sense. So what we're going to do is really numerically we're focused around 4. And I'll just go 1 above to 5 and 1 below to 3 just to get some context around it. So if I'm drawing, x is going to be defined from negative infinity up to 4, but not including 4. So let's go ahead and draw an open circle at 4, and we're going to have everything to the left here. And really, I could have written this without infinity. I could have just written this as x less than 4, but sometimes they'll include the negative infinity and positive infinity, so it's good to see an example like that. Okay, so this is giving us a second region that we can shade, and we're looking at 4 is less than x is less than infinity. So we're still not including 4, but we're going off to positive infinity. So I'm going to do the shade in the right-hand side here. So what this means is with my number line, absolutely everything is possible on this number line except for 4. We're just skipping over positive 4. And we're going to have a nice way of summarizing this with the set builder notation. But let's talk about the interval notation first. So with this one, we're going from negative infinity to positive 4. And I want to use the curved parentheses here because we'll always use curved parentheses with infinity. Also, we don't want to include 4, so we'll use curved parentheses there. Now, where they use the word or, we have a mathematical symbol. It's a union symbol, and really it's just a big capital U, essentially. So, big capital U. And then our union is with this 4 to positive infinity. So 4 comma positive infinity. And then we'll use those curved parentheses to show we're not including those endpoints. So this notation will be important because this is what we need for our set notation if we just want to skip over one single point. So we write this set notation and it ends up being a union of two intervals, where basically we're just excluding that point right there. Okay, our set builder notation. So we're going to have our curvy bracket, x is defined by, and really what we're saying here is that x isn't allowed to be positive 4. That's the only thing we want to not happen here. So yes, we could copy that inequality notation from that first column, but what we could also do is just write x does not equal 4. And that's great like that. Another form you might see is, in fact, let me just leave that there, and I'll separate some other forms you might see is x is defined by x is all real numbers and x cannot equal 4. That's another possibility. And one last possibility here, x is defined by, and we have this symbol x, and then it's kind of like this curvy E almost. And what we're saying is x belongs to, that's what this curvy E symbol means. And then we use this big capital R that has these double lines. This is read as x belongs to all real numbers, or x belongs to the set of real numbers. And then we would just go and x does not equal 4. Really we're going to focus on the simple form, but I just wanted to add these in just in case you've seen them before or if you come across them in your reading. But this should get us started for when we're talking about domain and range and how to talk about these intervals where our function is defined.